Welcome to Mr. Honeycutt's math class. We're looking at the shapes of functions and how they're actually graphed. The first one is the constant function. Okay, it looks like f of x equals some constant k, like k equals, we're going to use 2 for this. K in this case just means any number, okay? And I want you to see what's going to happen. So at f of -3, whenever I input a -3, it outputs a 2. So that output there is 2. So at -3, the output is 2. All right, when I input a -2, the output is 2. When I input f of -1, the output is 2. All right, for all of these, all the way down, the output is always going to be 2. That's what a constant function is. It doesn't vary, it just gives you the same output. All right, so it's outputting a 2. So regardless of what x is, the y value is the same. And then if you connect those dots, okay, you get a horizontal line. Okay, notice that's sort of counterintuitive that that you put in different x's, but the y value is the same. So a horizontal line is actually like a y equals k line, which is weird because normally we think horizontal, we think x's, but that's exactly why that's happening. It's because the x is varying, but the y is being held constant. All right, so looking at domain and range, the domain's all reals. The range in this case is just going to be k, which in this one is 2. All right, the left end behavior is 2, the right end behavior is 2. It's not increasing, decreasing, it doesn't have max or mins. So this basically, yeah, it doesn't have any of that stuff. Looking at the identity function, that's f of x equals x. So whatever we input is the output. So if I input f at -1, it's going to equal -1. Okay, so f at 0 is going to be 0. F at 1 is going to be 1. F at 2 is going to be 2. F at 3 is going to be 3. So graphing these carefully, these are my x's, these are my y's. Graphing these carefully, -3, -3, 3. It's going to be right there. -2, 2 is right here. -1, 1, 0, 1, 1, 2, 2, and 3. Graphing all those, connecting those dots, it looks like this. So notice, by the way, technically this is an odd function, so it actually has end behaviors. This is all reals. The range is all reals. The domain and range are all reals. So the left end behavior is -infinity. The right end behavior is +infinity, just like other x to the odd power functions. And it technically is an x to the odd, okay, because 1 is an odd number. So it's increasing for all reals. All right, it does not decrease ever. It does not have a max or a min. Okay, so that's not happening. Moving on to the absolute value function. Notice that the absolute value, whenever I input a negative value, will return a positive value. It gives the distance from 0. So this point right here is going to be, -3, 3. Okay, because these are my x's, my horizontal, and these are my outputs. All right, so this one, it's the absolute value of -2, which is going to be +2. Plotting that point is going to happen right there. Absolute value of -1 is going to be +1, and that point's going to go right there. The absolute value of 0, well, the distance from 0 is 0, so it goes right there. Absolute value of 1 is 1, so that's going to be the 0.11. Absolute value of 2 is 2, it's going to be the 0.22. Absolute value of 3 is 3, and that's going to be the 0.33. And we can see if this were to continue, it would look something like this. So notice the domain is all reals. The range, on the other hand, is 0 to +infinity. Okay. The left end behavior is +infinity, and the right end behavior is +infinity. So in this way, it's kind of acting like an even function. An x to the even function. Okay, now we even have some intervals for increasing and decreasing. So it is increasing from 0 to infinity, and it is decreasing from -infinity to 0. And there isn't a maximum, but there is a minimum at x equals 0, which is the point 0, 0. Right there. So that's the basic graphs and why they have the shape they have for the first three functions: the constant function, the identity function, and the absolute value function.